National Electrical Code (NEC) does impose an 80% safety factor on disconnect switches serving as the entrance point to an emergency generator. This is considered good design practice and is supported by several NEC articles. NEC Article 700.12b addresses the disconnect means. It states that disconnect means shall be rated for the ampacity of the generator conductors and shall have an interrupting rating sufficient for the maximum fault current that is available at the terminals of the disconnecting means. This means the disconnect switch must be appropriately sized for the generator's output and capable of handling potential fault currents. NEC Article 700.12c addresses overcurrent protection. It states that the overcurrent protective device for the generator shall be located ahead of the generator disconnecting means. This ensures that the generator is protected from overcurrent situations and the protective device is positioned before the disconnect. NEC Article 700.12d addresses multiple generators. It states that where more than one generator serves a given system, the disconnecting means for each generator shall be grouped together and identified. This is essential for safety and maintenance when multiple generators are involved. NEC Article 700.12f addresses accessibility. It states that the disconnecting means shall be accessible from the generator and from an area accessible to authorized persons. Accessibility is crucial for operation and maintenance purposes. NEC Article 110.14 addresses workmanship. It states that electrical equipment shall be installed in a neat and workmanlike manner. This article highlights the importance of quality and professional installation practices. Applying an 80% safety factor to the disconnect switch is a prudent approach. For a 300 amp rated switch, the maximum continuous load should not exceed 240 amps, which is 80% of 300 amps. This safety margin accounts for potential fluctuations, harmonics, and other factors that can increase the load on the switch. The provided scenario involves an emergency generator entering a building through a 300 amp disconnect switch. Measurements indicate a base load of 30 amps with spikes up to 271 amps due to 230 horsepower elevator motors. Although the spike reaches 271 amps, it's crucial to consider the duration and frequency of these spikes. The NEC doesn't explicitly state the 80% rule as a hard requirement for disconnect sizing in all emergency systems. However, it is implied through various articles emphasizing the need for adequate capacity and safety margins. Here is a breakdown of considerations. Firstly, the disconnect switch must be rated for the calculated load according to Article 220. This calculation should include all connected loads, considering demand factors and any applicable diversity factors. Secondly, Article 700.4 addresses capacity and rating. Emergency systems must have adequate capacity and rating for all loads supplied by the system. This includes consideration of inrush currents from motors and other equipment. Thirdly, the interrupting rating of the disconnect switch is also crucial. As per Article 110.9 and 700.12b, the switch must have an interrupting rating sufficient for the available fault current at its terminals. In the context of the elevator motors, it's important to consider their starting currents. Motors typically draw a significantly higher current during startup than during normal operation. This inrush current can be several times the motor's full load current. The National Electrical Code provides guidance on motor circuit protection and conductor sizing in Article 430. This article includes tables and guidelines for determining the appropriate size of conductors, overcurrent protection, and disconnect means for motor circuits. While the spike to 271 amps is below the 300 amp rating of the disconnect, the NEC requires that the disconnect be suitable for the continuous load plus 125% of the largest motor load, as specified in Article 430.110. This is effectively implementing a similar safety factor as the 80% rule. To ensure compliance, perform the following steps. Firstly, calculate the total connected load, including the elevator motors. Secondly, determine the motor full load amps floor from the motor nameplate or NEC tables. Thirdly, calculate 125% of the largest motor FLA. Fourthly, add the continuous load to the result from the previous step. Fifthly, verify that the disconnect switch rating is equal to or greater than the calculated value. Sixthly, verify that the disconnect switch interrupting rating is sufficient for the available fault current. While the 80% safety factor isn't explicitly mandated, it's a good design practice that aligns with the intent of the NEC to provide a safe and reliable electrical system. The NEC provides guidelines and tables for calculating motor loads and sizing conductors and overcurrent protection. Article 430 provides detailed requirements for motor circuits, including disconnects, overload protection, and short-circuit protection. This article should be consulted to ensure that the emergency generator disconnect is properly sized and protected. Several factors influence the selection and application of an emergency generator disconnect switch, encompassing both code compliance and practical design considerations. Firstly, ampacity is paramount. The disconnect switch must be rated to handle the full load current of the generator, inclusive of any potential overload or surge conditions. NEC Article 700.12b mandates that the disconnect means be rated for the ampacity of the generator conductors. Secondly, interrupting rating is essential. The switch's interrupting rating, measured in amps, must exceed the maximum fault current available at its terminals. This ensures the switch can safely interrupt a short circuit without failing. NEC Article 110.9 and 700.12b emphasize the importance of selecting a disconnect with an adequate interrupting rating. Thirdly, voltage rating must be considered. The disconnect switch's voltage rating must match or exceed the system voltage of the emergency generator. Using a switch with a lower voltage rating can lead to equipment failure and safety hazards. Fourthly, environmental conditions play a role. The operating environment of the disconnect switch, including temperature, humidity, and exposure to corrosive elements, must be considered. Switches designed for specific environments, such as those with NEMA ratings for weather resistance, should be selected accordingly. Fifthly, ease of operation and maintenance are important. The disconnect switch should be easily accessible and operable for authorized personnel. Regular maintenance, including inspection and testing, should be performed to ensure the switch's reliability. Sixthly, compliance with local codes and standards is crucial. In addition to the NEC, local building codes and regulations may impose additional requirements for emergency generator disconnect switches. Consulting with local authorities and qualified electrical inspectors is essential to ensure compliance. The location of the disconnect switch is also critical for safety and operational efficiency. Firstly, accessibility is key. The disconnect switch should be readily accessible to authorized personnel for operation and maintenance. Obstructions that could hinder access to the switch should be avoided. Secondly, proximity to the generator is important. Locating the disconnect switch near the generator minimizes the length of conductors and reduces voltage drop. This also simplifies the process of disconnecting the generator in case of emergency. Thirdly, visibility should be considered. The disconnect switch should be visible from the generator or from a readily accessible location. This allows operators to quickly identify and operate the switch as needed. Fourthly, environmental protection is crucial. The disconnect switch should be protected from environmental elements such as rain, snow, and direct sunlight. Enclosures with appropriate NEMA ratings can provide the necessary protection. Fifthly, coordination with other equipment should be considered. The location of the disconnect switch should be coordinated with other electrical equipment and systems to ensure proper operation and maintenance. Interference with other equipment should be avoided. When dealing with elevator motors connected to an emergency generator, there are unique considerations that must be taken into account. Firstly, motor starting currents are significant. Elevator motors typically draw a high inrush current during startup, which can be several times their full load current. The disconnect switch and associated wiring must be sized to accommodate this inrush current. Secondly, duty cycle is important. Elevator motors operate on a cyclical basis, with frequent starts and stops. The disconnect switch must be capable of withstanding the stresses associated with this duty cycle. Thirdly, coordination with elevator controls is necessary. The disconnect switch should be coordinated with the elevator control system to ensure safe and reliable operation. This may involve interlocks or other control features. Fourthly, compliance with elevator codes is essential. In addition to the NEC, elevator installations are subject to specific codes and standards. These codes may impose additional requirements for disconnect switches and other electrical equipment. The National Electrical Code, specifically Article 430, provides comprehensive guidelines for motor circuits, including disconnects, overload protection, and short-circuit protection. This article includes tables and calculations for determining the appropriate size of conductors, overcurrent protection devices, and disconnect switches for motor applications. When sizing a disconnect switch for an elevator motor, it's crucial to consider the motor's full load current, starting current, and duty cycle. The disconnect switch must be rated to handle the motor's full load current continuously and be capable of withstanding the stresses associated with frequent starts and stops. The overcurrent protection devices, such as fuses or circuit breakers, must be sized to protect the motor from overload and short-circuit conditions without causing nuisance tripping. The conductors supplying the motor must be sized to carry the motor's full load current plus any applicable deterring factors. The disconnect switch should be located within sight of the motor control center and be readily accessible for maintenance and troubleshooting. The switch should be clearly labeled to indicate its function and the equipment it serves. Regular inspections and maintenance should be performed to ensure the disconnect switch is in good working condition and operating safely. The National Electrical Code is a comprehensive set of standards that provides guidance for the safe installation and maintenance of electrical systems. It's essential for electrical professionals to stay up to date with the latest version of the NEC and adhere to its requirements. Emergency generator systems are subject to specific requirements outlined in Article 700 of the NEC. This article covers the installation, operation, and maintenance of emergency systems, including generators, transfer switches, and distribution equipment. The NEC emphasizes the importance of reliability and safety in emergency systems to ensure that critical loads are supplied with power during outages. The disconnect switch is a critical component of an emergency generator system, providing a means to isolate the generator from the electrical system for maintenance or in case of emergency. The disconnect switch must be properly sized and rated to handle the generator's output and be capable of withstanding the stresses associated with emergency operation. Regular testing and maintenance of the disconnect switch are essential to ensure its reliability and proper function. Electrical safety is of paramount importance when working with emergency generator systems. Electrical professionals should follow safe work practices, use appropriate personal protective equipment, and be knowledgeable about the hazards associated with electrical equipment. Lockout/tagout procedures should be followed when performing maintenance or repairs on electrical equipment to prevent accidental energization. Regular training and education are essential to ensure that electrical professionals are competent and knowledgeable about electrical safety practices. The National Electrical Code provides guidance on electrical safety practices, including working clearances, grounding, and bonding. Adhering to these practices helps to minimize the risk of electrical shock and other hazards. Emergency generator systems are designed to provide a reliable source of power during outages, but they must be properly installed, operated, and maintained to ensure their effectiveness. The disconnect switch is a critical component of an emergency generator system, providing a means to isolate the generator from the electrical system for maintenance or in case of emergency. The disconnect switch must be properly sized and rated to handle the generator's output and be capable of withstanding the stresses associated with emergency operation. Regular testing and maintenance of the disconnect switch are essential to ensure its reliability and proper function. The 80% safety factor is a good design practice to apply to the disconnect switch serving as the entrance point to an emergency generator, meaning that the switch should not be subject to more than 80% of its rating.